uh, what we have completed. Harsh, do you have any idea in the last class? We are doing meter bridge now.
Last class? Yeah, last class we did.
So
Yes, sir.
I want to ask
Sir,
you.
we finished balancing meter bridge.
Yeah, I know that, but I want to ask you. This thing has been completed in your school. Means your teacher has told you this thing in your school or not? Do you remember?
This thing,
Meet,
I don't
meet,
think so.
I don't
He
think so.
told us about meter bridge. He told us about meter bridge, but I don't
He,
think this balancing was done.
no. How he will tell you the meter bridge? Because meter bridge is not now the part of the syllabus. Yesterday I came to know.
It is not part of the syllabus?
No. Okay, just I am showing the syllabus also. Okay.
Okay.
But we have studied now, so don't think we have wasted our time, because when you will, knowledge is never wasted. You can say that simply.
Yes,
So,
sir. So the chapter finished.
it will take only 15 minutes to finish this chapter. Then we will study magnetism. So just I want to show you the syllabus of current electricity. Just wait.
Yes, sir.
I'm showing the syllabus. Just wait. Okay, so we have this physics, maths, physics, no?
Yes, sir.
We just wait. Now see this. This is chapter. Are you getting the screen now? So see this. Harsh, are you getting?
Yes, sir. Yes, sir.
So
Yes.
see this. In the electricity, you can see this meter bridge.
Yeah,
Delete
potentiometer.
potential
Yes, sir.
principle, and but we have done this series and parallel combination of resistors. Why we have done this? Because this thing will help you in calculating the EMF. Okay, that is why we have
Yes,
done
sir.
this. Okay, don't think
Yes.
we have just completed the series and the parallel combination, but it was deleted from the syllabus. We have done this for a purpose, because when you will do series and the parallel combination, what will happen? You will get to know how the circuit will be solved, and circuit is the part of your syllabus. Means the series and parallel combination of cell is the part of your syllabus. That this thing, series and parallel combination, will help you in that area. That is why I have taken. But meter bridge, I am just leaving. So for the meter bridge part, you can just skip it, because this is deleted from your syllabus. And for the meter bridge, we have just these two numericals I have written, but now no use of this. So now we will start the heating effect of current. So talking about the heating effect of current, what is the heating effect of current? Whenever the current passes through the resistance, heat is generated. Heat is generated.
Yes, sir.
And, okay, and
Yes.
this heat is the part of the electrical energy that we are supplying to the resistance. Okay, so in the heating effect of current, you can write the heading heating effect of current. Okay, and now, so suppose from the circuit I will explain it. So this is, suppose any this. Okay, suppose this is the battery here. This is the battery here, and here is the resistance R, and current is flowing like this. And when the current will flow through this resistance, heat will be generated. So you can say heat dissipated across resistor. And do you want the example? Or
Yes,
do
sir.
you
You
want
give
it?
the example. Yes, sir.
Already you know the example. The heating of your laptop is the example of
Yeah,
heating
yeah,
effect
yeah,
of
yeah.
current.
Yes, sir.
But in the wiring of the laptop, the wires have the resistance, so, and the current is flowing, and due to that flow of current, heat is generated. So it means our power is wasted. So what happens? You can see here. This is the power source, and we are supplying the power. Basically, we are supplying the power. Power is, I will tell you, rate of heat supplied per unit time is power. We are supplying a power, and our power is wasted here. Okay. So and so what is the cause of this heating effect of current? If you want to write the cause, then you can write due to collision of electrons and ions, a part of electrical energy dissipated as heat. So why the heating effect of current is taking place? Due to the collision of electrons and ions in the conductor. Okay. Now there is a term power dissipated. Power dissipated means I will represent it with capital P, and power dissipated is given by heat dissipated divided by time taken, heat energy, or you can say heat dissipated divided by the time for which the heat energy is dissipating. It is the power dissipated. And the formula of power we have already discussed in the capacitance, in the when we are discussing the resistances or the series and parallel combination. So power is given as I square R is the one formula. Another is V square divided by R, and third formula is V into I. So I is the current, this I is the current in the circuit, R is the resistance, V is the potential difference. Okay, already discussed.
Yes, sir.
Now if you want to calculate the heat energy, this heat energy is represented by capital H, then you will write P into T. From this equation you can calculate heat energy. So for the heat you can write I square RT. T is the time, small t is the time for which the heat is dissipating, and this will become V square by R into T. This will become VIT. So this is the formula for the heat dissipation. And these formulas are valid when the power is constant. Constant power dissipated with respect to time. Okay. Suppose if your power is variable, means the if variable power means, suppose if you have a time zone, means for a 1 hour. You have a 1 hour and you are calculating the power dissipation, and suppose for the 20 minutes the power dissipation is 20 watt, and for the next 20 minutes suppose the power dissipation is 30 watt. For the next 20 minutes the power dissipation, suppose the power dissipation is increasing or decreasing with respect to time. Okay, that time that power is the, you will say, power dissipation is of variable kind. When the power is dissipated with a constant rate, then this formula is valid. So if power is variable, you can say if power dissipation is variable, variable, then you can calculate the heat with the help of integration. P dot dt. Dt is the small amount of time in which the power is dissipated. And SI unit of power, do you know SI unit of power?
SI unit of wait, just
Watt.
watt, right? Watt.
Watt or joule per second. Joule per second you will get
Joule
from
per
here.
joule per second.
Joule heat, the unit of heat is joule and unit of time is second. So joule per second. And what is the name taken from the, what is the name taken from the James Watt?
Scientist.
Okay. Scientist.
Yes, sir.
1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. 6 watt, sorry. Not 6 joule. Okay, so you can just copy this. After that, we will solve a numerical, and this chapter will be okay. Just copy this. After this, there will be a very good numerical we will solve.
Yes, sir.
Completed, Harsh?
So just
and I think the this numerical this time will appear in your exam. The next numerical that we are going to solve.
so let's scroll down.
Yeah. This is power dissipated.
Yes, sir. Yes.
First, do you know what is density?
Yes, sir.
What is density?
The
Density
amount of wait.
means the mass
Yeah, amount of
upon,
mass per unit volume, right?
yeah.
Amount of mass per unit volume. Done, sir.
Okay, very good. So now we will have this last numerical of this chapter, and this is the number. So they are saying two wires of same mass having the ratio of length is given, and here suppose one wire is this and another wire is this. This is first wire and this is and length ratio. Suppose the length of this wire is L1 and area of cross section of this A1, A2 and L2. So ratio of length is given, means L1 divided by L2 is given 1 by 2. Density, ratio of density is given. So I am taking the density as sigma 1 by sigma 2. This is given as 1 by 3.
Yes, sir.
So sigma you can say I am taking here as density. And resistivity is also given, and resistivity is represented by rho 1 divided by rho 2. Resistivity is represented by R as for rho, and this is given as 2 ratio 1, 2 ratio 1. And they are saying this two wires of same mass, means this, suppose the M is the mass of this wire and M is the mass of this wire also, same mass.
Yes, sir.
Okay. So can we put this mass is equal to this mass? And what is mass? If we will talking about the mass, so mass is equal to volume into density.
Volume density.
Volume into density. Okay, just calculate the mass for the wire 1. What is the volume of wire 1?
Volume
Area
of
A1 into L1.
A1 into L1.
A1 into L1. And what is the density? Means sigma 1.
Yeah,
Okay.
sigma.
If you will calculate the mass for wire 2, you will write A2 L2
A2 into
sigma,
L2
sigma 2. And both masses are equal, so you will put M1
Yes.
is equal to N2. So from here you can calculate A1 L1 sigma 1 is equal to A2 L2 and sigma 2. Now A1 by A2 you can find from here, and why I am finding A1 and A2 I will tell you. So here you will get L2 divided by L1 multiplied by sigma 2 divided by sigma 1. So now what is L2 by L1 is 2. L2 by L1 is 2 na? Okay. Just put L2 by L1 as 2. Sigma 2 by sigma 1 is 3. So A1 by A2 you will get 6. Okay. So this is suppose your equation number 1. Now they are saying resistivity ratio are given, all the ratios are given, and these wires are connected one by one to the same voltage supply, okay. So now suppose you have connected both the wires with a same voltage supply. Suppose V is the voltage here you have connected, and V is the voltage you have connected to this wire. This wire voltage V, this wire voltage V. And after that they are saying the rate of heat dissipation. What is the rate of heat dissipation? Rate of heat dissipation is power. Is
Yes,
first
sir.
in wire is 10 watt, and from the unit also you can identify. Find the rate of heat dissipation in the second wire. Means P1 is given to us. P1 is the power dissipation in first wire, and that is given as 10 watt. And P2 we have to find. And what is the formula of power? V square by R.
Yes.
If you want to find P1, then you will write V square by R1. And if you want to find P2, then you will write V square by R2. Why I am writing both the voltage is same? Because here in both the wire the voltage is same. Okay, then now divide P2 by P1. P2 divided by P1, you will get R1 divided by R2.
R2.
Now what is R1 of the wire? R for the R1 you will write rho 1 L1 divided by A1. For this R2 you will write rho 2 L2 divided by A2. Further you will solve it, you will get rho 1 L1 A1, and this will become A2 rho 2 L2. Now from here P2 by P1 you will get, you have ratio of length L1 by L2 here.
Yes, sir.
You will have rho 1 by rho 2. Rho 1 by rho 2 means from here you will get rho 1 divided by rho 2. And A2 by A1 you will get A2 by A1. Now you do not have P2, you have P1 10. L1 by L2 is 1 by 2. Sorry, L1 by L2 is 1 by 2. So put L1 by L1 by L2 is 1 by 2. And rho 1 by rho 2. What is rho 1 by rho 2? Rho 1 by rho 2 is 2.
2.
2 divided by 1 you can say. And what is A2 by A1? A1 by A2 is
Sigma.
6.
Yeah, 6. Sorry.
A1 by A2 is 6. So A2 by A1 is 1 by 6.
1 by 6.
Yeah, 1 by 6. So just this 2 and 2 will cancel out. This power P2 will become 10 divided by 6. And you can calculate it, 5 divided by 3 watt. 5 divided by 3 watt is the power that will be dissipated in the second wire. Just a minute. Okay, now you can notice this down, note this question down. And I will say this question is a good question, so I am giving it a 1 star. Okay, just please copy this. And
Yes,
this
sir.
chapter now finished.
Finally.
For you, this chapter is finished. Harsh, do you know about the NEET examination in India?
Yes, sir.
IIT?
Yeah, I know.
Fine.
Like, I will give it. So,
Very nice. And all the best to you. Harsh, should I scroll down?
Yes, sir. You can scroll down, sir.
Okay.
So can you scroll up for a minute? Just 1 second.
Okay, okay, okay. No problem.
Okay, yeah, you can scroll down, sir.
So the next chapter is moving charges and magnetism according to the NCRT.
Yes, sir. I have also done that, so yeah, you can continue with that.
Okay, very good.
That chapter is also easy, like right hand rule, Fleming's left hand rule.
Actually, about that chapter, when we will introduce that, and then I will tell you what is the
Yes.
speciality of that chapter.
That chapter is small, right, sir?
That chapter is
Small, right? Like it's very small.
no, we cannot say that chapter is small. But
So
from
like
the with
in my
respect to
school we
the
finished in 2 weeks, sir.
so in 2 weeks, how many classes are there? Means
Like
how many
now,
classes? Okay, we can
on
also finish
in
with
explanations, there are 5 classes. That's
in 5 classes. Okay, we will try to finish it in 6 or 7 classes. We have only 2 classes in a week, na?
yes.
So Harsh,
Like you
can I
can do
take
extra.
Harsh? Can I
Yeah.
take the extra class of yours
Yes, sir.
if
You can take.
if it will be required?
Yes, sir. You can take, sir.
So you should tell me your free time. Means you should
Free
tell me the
time.
time.
You can
And
take on Sunday, Saturday.
Sunday, Saturday you are free. Okay,
Yeah.
okay, okay. I will inform you, and accordingly we will arrange that. Okay.
Okay. So can you scroll down?
Yeah.
Done, sir.
Okay, done. So now are you ready for the next chapter?
Yes, sir.
Okay. First introduction part.
The
I am telling you
only
the
important, like one of the important thing is only Biot-Savart's law. Mu 0/4 by ideal. Sine
no.
theta
There
by
are
r square.
Ampere circuit law is
Yeah, like in the first part of the chapter.
yeah, I know that. So the thing is the I will tell don't see this. This is
Yeah,
nothing.
yeah, okay. Okay.
This is the number of periods. Okay, no problem with this.
Yeah,
So you can see here this is the magnetic effect of current and magnetism. This is unit third. If you are talking in terms of unit, so you will in this unit you will have 2 chapters: moving charges and magnetism and matter. So and unit number 4, electromagnetic induction and alternating current. We will discuss this. And in this, there are 2 chapters. So electromagnetic induction and alternating.
alternative
So the
current.
combination of that will, if you will do both all these units, you will get 17 marks. Means 17 marks will get from all.
Yes, 4
Means
chapters.
means accordingly you can get like 10 marks from here
Yeah.
or 7 marks. I am not saying, matlab, I am not saying it's surely that 10 marks will come from here. Either you can
Yeah,
get
it's
7 marks. It depends on the examiner. No problem, sir. So moving charges and magnetism.
magnetism.
So this is the syllabus, okay. But I want to tell you which part is deleted. Cyclotron is deleted.
Yes, sir.
That I want to tell you. Cyclotron. And okay, fine. So now I want to tell you about this chapter. What happened uh, about 2000 years ago? We know the electricity and magnetism from
Yeah.
2000 years. Okay, we know the electricity and magnetism. But uh, if we are moving backward 200 years ago, means 200 years ago, it was founded that electricity and magnetism are related. If you have
Yes,
a
sir.
electricity, if you have a
Magnetism
electricity,
field is created. Yes, sir.
yeah, magnetic field, you can produce the magnetic field. If you have a
Yeah.
magnetic field, you can produce the electricity. Means they are interrelated. So for this, there is a term. Someone given the term. I do not know the name of the scientist. I think the Maxwell electromagnetic or electrodynamics combination of it. Okay, no problem.
Yes, sir.
Fine. So this is our chapter. Magnetic effect of current. You can write or you can write moving charges and magnetism. According to the NCRT, this is moving charges and magnetism. So moving charges and magnetism. Moving charges and magnetism. So in the introduction part, in the introduction part, as we have discussed electric field in the chapter electrostatics, we have uh, we were discussing about the electricity and electric field and all that. Uh, in the electrostatics, we have discussed about the electric field, and in the current electricity chapter, we have seen that how the electric current is related with the electric field. So now in this chapter, we will define a term magnetic field. We will define a term magnetic field, and for that we should know from where this magnetic field came. Okay, what are the sources of magnetic field? Sources of magnetic field. So sources of the first source of magnetic field, you can generate the magnetic field with the help of current. That all the things we will see. So the application of this is solenoid. We will study solenoid also. And current means you can say moving charges. Current is basically the charge in motion, or from the bar magnet. No problem. And another is, or you can do it with a bar magnet. Now, another source of magnetic field is our Earth. Earth also produces the magnetic field. The Earth also is a source of magnetic field. So, Earth's magnetic field, you can write. Earth's magnetic field. And another source of magnetic field is the electronic spin. In chemistry, you have electronic spin +1 and -1.
Yes, sir.
So this is basically related to the quantum mechanics. So we will mostly we will discuss this part, and we will discuss this part, Earth magnetic field. Mostly we will discuss this part. So the term that I am going to define is the magnetic field. What is magnetic field? That I will define here. and this magnetic field is a vector like the electric field, and this magnetic field is represented by
B.
yeah. So as the electric field says that if you have a charge and around that charge, if you have a charge around that charge there is a field, and if in that field if another charge is entering, that charge will experience the electric field. In the same way, if you have a magnet, around that magnet there is a region or a space. If you will, if another magnet will enter in that magnetic field of the magnet that you have, then that magnet also experience the magnetic field or magnetic force. Okay, so you can write the definition same as that of electric field. You can write as this as space around a magnet, where it's, or you can write spins around a magnet when another magnet enters in its space. That magnet experiences a magnetic force, or you can write space around a magnet in which its magnetic properties exist. So these are the two definitions. So this I am explaining how these things are happening. Suppose you have a magnet like this. Magnet have two poles, north pole and south pole. And suppose this magnet have some region, space around it. This is the spherical region. Okay. Suppose I am taking a region. Okay, this is the region around this. This is the region around this magnet, and if another magnet you will take, like you have another magnet like this. This is south pole and this is north pole. So on this magnet, due to the magnetic field of this source magnet, this magnet will experience a magnetic force. Magnetic force. Or this magnetic field is also, you can say, the strength of magnetic field is known as the magnetic field intensity or the magnetic flux density. The strength, like the strength of electric field, na electric field intensity, we have magnetic field intensity.
Yes, sir.
The strength of magnetic field I will write magnetic field like this, okay? In short. Whenever required, I will write magnetic field like MF, okay?
Yes, sir.
So the strength of magnetic field is also known as magnetic field intensity, magnetic field intensity, or magnetic flux density. Magnetic flux we will discuss. So the density of magnetic flux is the strength of, this is the theme, okay? And talking about the SI unit, if you will, so the SI unit of magnetic field is Tesla.
Tesla
Nikola
or
Tesla.
Gauss.
Yeah. Tesla or Gauss is the
Gauss.
CGS unit. We
Yes,
were
sir.
also was the scientist. We were per meter square.
Yes, sir.
And CGS unit, if we will talk, then this is the Gauss law, na? Gauss is the name of scientist, and this is represented by capital G. So this is the thing, and one conversion is there. 1 Tesla is equal to 10 to the power 4.
10 to 1 minus 4.
4 Gauss. Okay, just note this down, and after this we will discuss the Biot-Savart law. Biot-Savart
Yes,
law.
sir. Yes. So can you
this
scroll
is
up?
it's called up.
Yeah. Okay. Yeah. Done.
Okay, fine. So this is all about the sources of magnetic field and about the magnetic field. What is the magnetic field? What the magnetic field is? Okay. Like the electric field, we have magnetic field here.
So can you scroll down? So scroll down. Done, sir. Done, sir.
So the next topic is Bio-Savart's law. T is silent in bio. So
Yes, sir.
bio,
DB is
Bio-
proportional to DL and all those
Yeah.
things.
all these things. So what will happen here? Now you will calculate the magnetic field at a point. If you want to calculate the magnetic, earlier we have defined what is magnetic field. Suppose if you want to calculate the magnetic field at some point, then you will use this Biot-Savart law. And there are the conditions in which you will use this law. So the condition means suppose you are having a wire like this. Okay, you are having a wire like this, and current I is flowing in this wire. Okay, current I is flowing in this wire, and suppose there is a point here. I am supposing this as point P. This is a wire and current is flowing in this direction in this wire, and there is a point P here. Okay, and at this point P, if you want to calculate the magnetic field, then due to this whole wire, suppose this is the whole wire, this and this is AB is the wire. So what we will do, Harsh, means due to this whole wire, if I want to
Yeah.
we will apply
By service.
no.
We'll
Law,
join the line and then we'll make a angle.
no. Actually, Biot-Savart law is not cannot calculate the magnetic field due to whole wire. It can only calculate the magnetic field due to a small element of wire only. Due to a small element of wire only. So suppose I am taking a small element here, and this small element is DL.
Yeah.
Okay. And DL, and this DL is now, this is DL. Okay. This DL is the small element. Okay.
Yeah.
Okay. Now we will join.
Yeah.
And suppose this is a distance R for this distance R is the distance between this element of this wire and this point P. Okay. And one thing more. This element now is very small, very small. You cannot imagine how small this element is. So okay, I'm just joining it from here. And if suppose this element DL is making an angle theta, this DL element is making an angle theta with this R.
Theta. Yes, sir.
So according to the Biot says that the magnetic field is small, and this element is very small, so that is why the magnetic field will be also small. So the small magnetic field is directly proportional to the current flowing in the wire. DL means the element of the wire, and sine theta, and divided by the R square.
Yes,
And
sir.
when you will remove this proportionality sign, you will write this Ki
Ki IDL sine theta
Sine
by
theta.
R square.
But the interesting thing is here K has some value.
Yes.
He founded that K has some value, and this K in SI unit, if you want to find in SI unit, K have the value mu naught divided by 4
by
pi,
4 pi.
and this is equal to 10 to the power minus 7. And
4.10
Tesla meter
ampere
ampere
per
inverse.
yeah,
Per ampere. Okay, that is fine.
yes, sir.
Okay, you are right. And now, what is this mu naught? This mu naught is known as
Permeability
the
of free space.
absolute, or you can absolute permeability of the free space. Okay, very
Yes,
good.
sir. 4.10 minus 7.
Yeah. Absolute permeability.
Yes.
Of free space, and free space is also you can call it as air. Free space, you cannot call it free space as air, you can assume free space as air. Free
Yes, sir.
space or air. And one thing we have already discussed, that what is this?
Epsilon naught.
Epsilon naught, but what is the name of this? The name of this
Permeability.
absolute permeability, permittivity.
Yeah. Permittivity
This
of free space 8.85 by 10
is,
minus.
this is absolute, that epsilon naught is absolute permittivity. This is absolute permeability. Okay.
Yes,
So
sir.
don't confuse. So now, if I want to talk about this mu naught, or what is the absolute permeability, so you can write one point here. This absolute permeability tells the you can write absolute permeability tells the effect of medium on magnetic field. This is one point. Another point is different mediums have different absolute permittivity. Different mediums
Yes,
have different value of permeability. And if you are writing the permeability for some medium, then you will write like this. This is the permeability for some medium. Medium other than air. What other than air means? Water, oil, gas. So this is the and this is in the chapter natural magnetism. We will discuss all these permeability and all that. So this is the Biot-Savart law. And Finally, if I want to write the Biot-Savart law, how I will write? I will write dB is equal to, I will put the value of K.
Yeah, mu 0 by 4 pi
Mu
ideal
0 divided by
sin theta
4
by
pi
r square. Ideal
ideal
sin theta
sin theta
by r
divided
square.
by r square. So this is the formula, very important formula that you should learn. And remember that this is the this magnetic field is not for the whole wire.
Yeah, it's for
This is
the length,
elemental,
small
and
length.
I am defining all the term. I is the
Yes, sir.
current flowing in the wire. DL is the
Small part.
small element, you can write small
Yeah,
element
small element.
of wire, and theta angle
Angle
between,
between the midpoint joining in the line.
yeah, angle between DL vector
Yeah.
and R vector. Now this DL vector I will explain it later. What is DL
Yes.
vector? Okay, just let me explain what is DL vector. So DL vector is the vector having the magnitude of DL and direction of current. Okay, DL is the
Yes.
vector having magnitude as DL and direction of current. Because for the vector we should have direction, magnitude, and as well as direction. So for the magnitude, it will have magnitude of DL and direction of current. And this R is the position vector. R vector is the position vector. Position vector, you can make this R as a position vector. Okay, you can make this R as a position vector. Okay, fine, got it?
Yes, sir.
Okay, one thing I want to write here. If you want to write this law in vector form, and this vector form is equally important, like we have discussed, means some other teachers has discussed with you Coulomb's law in vector form,
Yes,
as
sir.
we have Biot-Savart law in the vector form.
Vector form.
So when you will write it in the vector form, you will write first this vector, and you will write this mu 0 divided by 4 pi, and you will write I, and you will write DL vector cross R vector divided by R cube. So why this R cube is coming? Just see why this is coming. When you will open this DL cross R, you will get DL into R into sine theta. So R and R will cancel out. You will get R
Yes,
square
sir.
again. So again you will get this form. From this vector form, you can get the scalar form also. Okay. So just see how you will get the scalar form. Mu naught divided by 4 pi na, and this is I. When you will open this cross product, you will write DL into R into sine theta. Okay, and n cap is equal to 1. If you are taking the magnitude, then n cap is equal to 1. So here is R cube. Now this R cube is cancel, and here it will be square. So you will get mu naught divided by 4 pi IDL sine theta divided by R square. Okay, so in this way you can get this. So no need of this. This is just for your understanding. So write this formula in the vector form, and this vector form is very important for calculating the direction.
Yes, sir.
Okay, just please okay, just let me complete this. After that you can write this. Suppose if I want to write this Biot-Savart law, this is the actual Biot-Savart law. Okay,
Yes,
this
sir.
actual Biot-Savart law means this expression tells us the magnitude as well as the direction. From this expression we can get the magnitude as well as the direction. So if I want to write this Biot-Savart law in terms of current density, I want to write current density. Current density we have discussed J. J is the current density and this is current divided by area. Okay, current density
Yes.
is the current divided by area. In the current electricity, we have just finished the chapter. So if I want to write this formula, if I want to write this in this terms of current density, then how I will write? So current density is this. Okay, so from this current density is this is J is equal to I divided by A. From here you can calculate this I is equal to J. Now put this I in this equation. Suppose I am supposing this as equation number 2 and this is as equation number first. So now I am putting the value in equation number second. Put I is equal to JA in equation number second. Then put it, this is dV vector. This is mu 0 divided by 4 pi. This will remain same. Instead of I, you will write here I into instead of I, you will write J into A, and other things will remain same. DL vector cross R vector divided by RQ. Now, do you one thing I want to tell you, suppose you have this wire and this wire have length L and having the cross section area A. Suppose if you want to calculate the elemental volume dV, dV is the elemental volume. So for this elemental volume, what you will do? You will multiply this length, this small length. Means suppose you have just DL length you have taken. So you will write length DL into area. Okay?
Yes, sir.
Or you can write A into DL is your small volume dV. So when you will substitute all the things, so you will get mu naught divided by 4 pi mu naught, and this A into D, this A into DL will come out and A into DL will become dV, not dV, become only dV. Okay, and this J will come here and this will be like this and here will be R cube. So this is the form that can be asked in the examination. Write
Yes,
the
sir.
Biot-Savart's law in terms of current density. Okay.
Yes,
So
sir.
suppose if I want to write the current density, not the current density, Biot-Savart's law in terms of velocity of charge. We know that this is the conducting wire, and in conducting wire there are charges and there are the velocity of charges also. So in terms of
Yes.
velocity of charges, in terms of velocity of charge, and now you have this wire and you have just taken this and a current is flowing like this. You have taken this small element dl. Okay, so the velocity of charge, velocity is, what is the velocity, or if you are talking about the magnitude, then what you will say, distance divided by time is the speed, or speed is, and for the velocity of charge, suppose v is the velocity of charge, so you will write this as dl vector divided by dt. Means from this dl, the amount of charge passing in dt is the velocity of the charge. So this is just the velocity of charge. dl by dt is velocity of charge. Now can you find dl from here? This will become velocity of charge into
Velocity
dt,
by. Yes, sir.
into dt. So Now you can put this equation. You can put this equation in equation number second. This is the equation number second. You can put this. Okay. So you have this equation number second here. Just put the value of DL here. One thing left. This thing is clear. Now we will talk about what is charge and current. The relation will be the charge and the current. So keeping it aside, current in the wire will be charge divided by the time,
Yes.
dq divided by dt. If you want to
Yes, sir.
find this dq, then you can write this I into dt. I into dt you can write. Okay, no problem. No requirement of this. This is I we have. Now what you will do, you will just put this value of I in this here. You will put this I here. Okay.
Yes, sir.
Put I in second. I means the value of I you will put. So you will get dv vector is equal to mu 0 divided by 4 pi. Instead of I you are putting dq by dt. And this will remain same, dl vector into r vector cross r vector. And here we have r cube. Now this dl by dt, what is dl by dt? dl by dt is no requirement of this.
Yes.
dl by dt is the velocity of the charge.
Yes, sir.
So dv you will get mu 0 divided by 4 pi dq. dl by dt can be written as velocity of charge into r divided by r cube you will get. So this is the Biot-Savart law in terms of velocity of charge. So someone can ask you that write the Biot-Savart law in terms of velocity of charge. So there is one last case. If there is any other medium, then how you will write Biot-Savart law? For any other medium. Other medium other than air or vacuum. So how you will write? You will write like this. dv is equal to mu 0 divided by 4 pi, and
4
you
pi.
will multiply this mu 0 with mu r, relative permittivity, and
Yes,
all the
sir.
things will remain same. This will become I. This is dl cross r vector, dl vector cross r vector divided by, this is divided by r cube. Okay. So, and now what is mu naught, mu r? And mu r is the relative permittivity, mu suffix r is the relative permeability. Relative permeability, and this relative permeability is much greater than 1 for ferromagnetic material. We will discuss this ferromagnetic material in natural magnetism. Ferromagnetic material. Okay. For paramagnetic, for all the things we will discuss, ferromagnetic, paramagnetic and diamagnetic. We will discuss it later. Mu r is just greater than 1. Just greater than 1, not much more greater than 1. And mu r is less than 1. Mu r is less than 1 for the diamagnetic.
Yes.
1 for diamagnetic. For diamagnetic material. So now you can copy all the things. This is all about the Biot-Savart law.
Yes,
Okay, I
sir.
am zooming it out, and this law is very very easy also.
Yes, sir.
Just
Yes.
and uh, now we will talk after this. The direction part is very very important. This part is easy. Direction part is important. Okay, just note it down. Harsh, should I scroll down or you are
Yes, sir.
writing?
Yes. 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 You can scroll down, sir.
Fine. Just scrolling it down. Okay. Is it fine now?
Yes, sir. So you can scroll a little bit up.
Little bit up. Okay.
Yes. Thank you, sir. That's
Okay, fine. Is it a matter of push or not? Harsh, completed?
yes, sir.
Should
Yes,
I?
I can scroll down.
Harsh, you can ask me when you have completed. No?
Yes, sir. Yes.
So this thing, keep in mind this thing. How I have written this elemental volume. Elemental volume means the small volume of anything, of any uh, geometry, or you can say cylinder, cone, and all that.
Yes, sir.
So you can get at least you can get question from here like write the Biot-Savart law in terms of current density for 2 mark.
Yes, yes, sir.
In terms of velocity of charge for 2 mark you can get. So like this you can get.
Yes, sir.
And for the numerical part you have to follow that
Formula.
formula, this formula and that
Yes,
formula.
sir. 4 pi pi
Hmm.
mu 0 by 4 pi ideal by standard hours.
But just complete this, then I will tell you one interesting thing about this. And time is up now, I think.
Yes.
The direction part is very, very important.
Yes, sir. Can
Should I scroll down?
so just now I'll write the head.
Okay, okay, okay.
Yes, sir. You can scroll down, sir.
Yeah. Harsh, when you are free, you can tell me, okay, for the extra class.
Yeah. Sir, I'll message you, sir. I'll message you.
You have my number also, okay?
Yes, sir. I'll message you.
Yeah.
So this week or from next week?
From next week, I think this week we are at a safe level.
This week you can also take because I'm free on Saturday and Sunday.
Saturday and Sunday. Okay, I will see, check my schedule and then I will tell in the
Done,
next
sir.
class. Okay, completed. So,
Okay. For any other.
for any other. This is the case like when you apply the Coulomb's law for any other medium. In Coulomb's law can also be applied for any other medium when we have
Yes.
two charges placed in some different medium. So this is like that. So in the next class we will discuss the direction of magnetic field because I am having a class after this.
Yes, sir.
So just I will tell you the right hand thumb rule for your understanding and we will discuss that.
Right hand thumb rule, yes, sir. Okay.
Yeah.
The thumb gives the magnetic field and.
Yeah. Okay, we will discuss the right hand thumb rule and or the direction of the magnetic field in the next class. Okay, so your current electricity has been completed.
Yes, sir.
Okay. And hopefully this will also be completed on time.
Done, sir.